Welcome. Rate of change. This is regarding how a particular quantity changes with another quantity. For example, how the distance changes with time, how the amount of say amount of a drug changes with time in a blood, and it how does what is the rate at which these changes occur is what we are going to deal with, and calculus is going to help us on this. Now let's see. Consider a function like this. You know that this is x squared or something. It's a parabolic curve, whatever. It's a you can just take this as y equal to f of x, some function. And if you consider this point, the rate at which the curve changes at this point is like this, which means this is nothing but the slope of the line at that particular point. And we have dealt this with I mean in another video regarding how the change is actually the slope of the tangent, and this slope of the tangent is dy dx, and this is also done before. So at this point the curve changes as the slope of this line, but if you consider another point here, then you will say that the slope changes, thus the curve changes at this rate, which is more steep than what you had here, which means the curve changes faster in this place than this area. Okay, because the tangent is much more steep than the tangent in this place, right? Therefore the rate of change is higher here than in this place. Okay, so because dy dx is at this point, which is the slope of the tangent, is greater than the dy dx at this point. Therefore dy dx actually gives us the rate of change for any function. Okay, so if you can model any concept, any aspect into a function, then if you find dy dx, then you are finding the rate of change. So that's as simple as that. So let's consider some questions. Very common area where you find rate of change, where you find change first of all, is population growth. So it could be human population, it could be bacterial population, or it could be any animal or insect population. So all of them, they actually change over time, right? There is a change of population over time, which means if you graph it, you'll have a time here and the number of whatever you are considering to be your y values, right? Which means you're having a growth model, which is usually a growth model because population usually increases. So this is called a growth model. Okay, and what is at time t equal to 0? The function would be like this. It could be anything, but for example, it's just growing up as time goes by. And if you start at time t equal to 0, which means you are considering the population data, this is time t equal to 0, you are considering the data for, say, for example, population number of people at a particular place, and you are starting with 1000 people at a particular area, which means this is your initial value. So you start with some initial value at t equal to 0, and then you consider the function, and then as you find dy dx for this, you get the rate at which the population changes at every point. So this is a typical question on population growth. Under certain conditions, the spread of E. coli, it's a type of bacteria, and this is modeled by means it's using the data we have made a regression function here, modeled by an exponential function here, where t represents time in minutes, okay, and n naught represents the size of the colony when it starts, which is, as I said, when t equal to 0. So if you are considering an exponential function at t equal to 0, it is n naught. It starts at the value of n naught, and then it starts increasing in exponential rate of e to the power of 0.23 times the time. F of t represents the size of the colony, which is thus the number of bacteria present at a particular time. The typical question could be, what will be the rate of increase of the size of the colony, which is f of t. This is the size of the colony. If we just said f of t represents the size of the colony, so rate of change of f, which means f dash of t. Okay, so this is what we are supposed to find now. Just find what is f dash of t. So we know that if f of t is this, then f dash of t would be n naught times 0.23 e to the power of 0.23 t by the rules of derivatives. So this would be the rate of increase of size of the colony at any time t minutes, because we give the answer in t. And if you want to find the rate of increase, the rate after 10 minutes or after 25 minutes, what you need to just do is find f dash of 10 or find f dash of 25, or whatever the question is asking you for. So the basic idea is, if you're given a function and if you're finding the rate of increase or rate of decrease of that function, you are finding the derivative of that. Okay, another example for rate of change is decay and half-life. I'm sure you know what is decay of a radioactive substance. A radioactive substance emits some radiations, and as it emits, it decreases in its size, or it decreases in its weight or whatever. So this is a decreasing model. This is not a growth model. This is an example of decreasing, because the amount of the radioactive material is going to decrease with time. Therefore, this is a decreasing model. Maybe it looks like this, right? Again, it starts at some point and it decreases from this. So at t equal to 0, you start at some amount of the radioactive substance. So as you can see, there is an example here. If we start with 100 milligrams of radioactive substance, and if the number of milligrams of this substance is decreasing with time, which is the independent variable is time in years, then f of t is equal to 100 e to the power of negative 0.13 t gives you the amount of the substance at a particular time t, right? This is the number of or amount of radioactive substance or size of the substance, whatever you can call. You can use any word there. Okay, and what is half-life? Half-life is the time taken for this substance to become half its original amount. So in this case, if you are starting with 100 and if it becomes 50, and what's the time taken for it to become 50 would be the half-life of this particular substance. Okay, so if you start with 1000, what's the time it takes to for this substance to become 500 would be the half-life time for that particular substance. Okay, so it's whatever you take here, half of this amount would be the time taken for bringing that to half of its original amount would be the half-life of the substance. Now the question could be, find the rate of decrease, it's not increase of this, find the rate of decrease of this radioactive substance after 8 years. Okay, so this is what you are supposed to find. Let's just understand what it looks like on a graph. So this is the question written again. Let's see what happens to the graph here. You can see that the curve is in the green color, and as the time moves, this is the time, as the time moves on, you can see that the slope changes. The slope is decreasing on the negative side. So you can see that the slope changes, and at this point where t equal to 2, it was minus 10, and we need at t is equal to 8. So at t is equal to say some 5, it's negative 5 point, and it's getting reduced, and we are looking for what is the slope at 8, which is negative 4.6 or something. Okay, so this is what exactly we are looking for. So going back, this is your question. So how do you do it this analytically without the graph? It's very simple. What we do is we need to find the rate of decrease, which means we are finding the slope of the tangent at t equal to 8 years, right? Which means we need to find f dash of 8. That's it. So find f dash of 8. First find f dash of t, which is 100 times negative 0.13 times e to the power of negative 0.13 t, and just find f dash of 8 in the substituting the t value to be 8. And you will get the answer as negative 4.6 as we saw in this graph. Next example could be on reaction of drug. What does it mean by reaction of drug? See, if a drug is administered into the blood, like you take some antibiotics, and then you say you take some 50 mg, that is 50 milligram of a drug into, and it's been injected in your body. Then it starts reacting with your blood, and then say your doctor would have advised you to take another 50 milligrams after say 8 hours. Why? Because this would have come to 0, and then you need another 50 milligrams to keep you going on with the antibiotic. Which means that the original drug amount of drug has been reducing as the time goes on. Therefore, the amount of drug present in the body after the administration starts decreasing at a certain rate. It depends on the drug and the initial amount given. So if you are given 100 milligrams, maybe it's not going to take 16 hours, it will take the same 8 hours, but the rate would be faster or slower. So it all depends on the drug and the initial amount given, and there are so many constraints on this thing. But the basic idea is there is a rate of decrease of the amount of the drug inside our body. So if you can model the amount of drug with f of t as amount of drug at any particular time, then f dash of t would be the rate at which the amount of the drug inside the blood starts decreasing. Okay, let's have a typical question here. The amount of new experimental drug present in patient's blood is given by g of t is equal to 5 e to the power of negative 0.3 t. As time changes, it changes. So you can see that at time t equal to 0, the initial amount which is given to them is 5 milligrams. It comes from here. So it's easy to identify this, where t is positive and where t represents the time since the drug was administered in hours, and g of t represents the amount of drug at any time t. It is also measured in milligrams. The question: what will be the rate of change of amount of drug at any time t? So rate of change of the amount of drug. So this is amount of drug. Therefore, rate of change of g of t is g dash of t, which is easy to find using the rules of the derivative. So this is the rate of change of the amount of drug at any time t. Now the specific question is what will be its rate 4 hours after the administration. So you are finding g dash of 4, which is 5 times negative 0.3 times e to the power of negative 0.3 times 4. Okay, some common rate of change problems. Those were more specific, and these are, it's very common here, very simple and common and very practical problems. You can have ink drop spreading on a blotting paper. We'll be discussing each one of them soon. Blowing a balloon, where there is rate of change. These are the some of the examples where you can see rate of change. Sand falling through a conical filter or any type of filter. Water flowing out of a tap. A sliding ladder. So these are very common questions and very common ideas where rate of change would be implemented. So let's start with ink drop on a blotting paper. So there is an ink drop on the paper, and you see that once if it is a blotting paper, it starts spreading around. And what is increasing here? You can see that the radius of the circle, it's in a circular it's assumed that it's in a circular shape. Therefore the rate, what are the changes in this particular thing? The radius is the main thing that changes. As the radius changes, the circumference changes, and as the circumference changes, the area also changes. So there are three things that change here just because it's bloating, it's spreading around on the paper. Okay, so we can call this as C, we can call this as A. So there is a change of radius, there is a change of area, and there is also a change of circumference with respect to time. Okay. Question: the radius of a circular ink drop spilt on a blotting paper increases at the rate of 0.1 mm per second. This is the rate at which the ink drop spreads, the rate of the radius, which means dr dt is 0.1. and if you want, you can use the units. What will be the rate of change? So some d something is being asked, which is d of dt is being asked, of what? Of area. So dA dt is in question at 5 mm. So at this, so you can see that if you have a rate of decrease, so you are asked to find the slope of this point, the function at a particular point where it is 5. Okay, so you need to find the slope and then you need to substitute the 5 in that, which means you need to find the dA dt, and then in dA dt you need to substitute 5 mm. Do not substitute anywhere inside. Okay, so what is the connection between first A and R? The area of a circle and the radius of the circle. Obviously it is pi r square. So this is the first thing that you need to think about. What is the connection between the question given or the information given and the information asked? If you were asked to find the rate of increase of the circumference, then you should have used the formula c equal to 2 pi r. So depending on the question, you need to make the equation first. So dA a equal to pi r square, because you want area's rate of change. Now you need dA dt. Therefore dA dt with respect to t on both sides, pi r with respect to t would be dr dt. Okay, you can interpret this as a chain rule or even as a rule on implicit functions. So this is how you change this to this. This is the second step. Now you need to find dA dt. Therefore dA dt is 2 pi r times dr dt is given as 0.1. This is in general what is dA dt for this question, but a particular value for dA dt would be when r is 5 mm, which means you are substituting 2 pi 5 and 0.1, and you can find the answer here. That would be your answer for the rate of change of the area when the radius is 5 millimeters. Okay. Next, the next concept that we were discussing is blowing a spherical balloon. Now let's see, this is a balloon and it's increasing in size as you blow the air into it. So first consider what are the components that are changing inside this balloon as it gets bigger and bigger. Obviously it's the radius, right? As the radius increases, in this say you have surface area which increases because it's three-dimensional, and also volume. So these are the two things that change as the radius changes. So you have the basic change as the radius change, and then you have the surface area change, and then you have the change of volume. So these are the three things that change inside as the balloon gets bigger and bigger. So the question could be anything given and any other rate being asked, but you need to know what is the volume and what is the surface area of a sphere. You know that the volume of a sphere is pi r cube, and this is 4 pi r square. So you need to know this so that you can make the equation, and then you can find the derivative, and then you can substitute them. Let's see an example. The radius of the balloon is increasing at the rate of, so which means obviously dr dt is 10. So this is given. At what rate? Volume. So go for the volume, 4 over 3 pi r cube, and you need the rate of the volume, right? Which means you need dv dt. This is what is asked, and at r is equal to 15. So this is the question. Now you just find the dv dt, which is 4 over 3 times 3 pi r square, which means 4 pi r square. Okay, this is dv dt, and you need to find, okay, you missed something here because this is not with respect to r but with respect to t. So r cube would be 3r square, on derivative with respect to t would be 3r square dr dt. So that's 3r square dr dt here. Substituting the values for r as 15 and dr dt as 10, so you'll have 4 pi 15 square times 10, whatever the answer is, you can give it here. Okay, so this is the rate of change of volume, and please give the unit properly. This is cubic centimeter per second because it's change of volume. Okay, now sand through a filter. We are considering a conical filter here. So this is a conical filter, and there is sand in it, and it's going to drop out of the filter, which has a rate at which it flows down, right? So what are the changes that's happening here? So many changes in this place. So this is a conical filter which has a circular base, and it has a height, and it has a radius here. So as the sand comes down, you can see that the radius So this is your cone. So the radius gets decreased as well as the height gets decreased. Also the slant height, also sometimes in some questions you will be asked to find connect the decrease in the slant height as well. So you have three things that are basically getting reduced linearly. But what are the other things that are getting reduced? Surface area of this as usual, right? You can see that the cone actually gets reduced. So surface area gets reduced, and of course volume gets reduced. So you need to know surface area and the volume. The surface area would be without the top or with the top, it depends on what you are talking about. So usually it's volume that deals with this question. So volume of a cone is pi r square h, and you need to remember this. Sorry, pi 1 over 3 pi r square h. So typical question would be, so what are the changes here? So you have a change like this, right? You have this is the basic idea. This is not a simple question, direct question, because not one component changes. There are three components at the same time which changes here. Okay, so you need to consider this triangle, two triangles in fact. So this is fixed, say r1, and this height is fixed, h1, and this L is fixed. What is changing here is this is L, which is changing, R changed, and H is which is also changed. Okay, as the sand comes down, the R changes, H changes, and everything else changes. So if you see the triangle, you have two similar triangles. Therefore you can find the ratio as R1 over R is the same as H1 over H, which is also same as L1 over L. So this is what you need to remember. Whatever you want, you can take up. Say if you want to connect the radius and height, just take the first two ratios and you can interchange R and H. If you are connecting radius and slant height, you can take this and this and you can manipulate it. Basically, when there is a cone problem and when there is a rate of change of a cone, then you need to consider the relation between any two variables, or H or L or HL, whatever, but you need to have the relation in this form. You need to remember this type of similar triangles. So let's actually go into a particular problem. Sand flows out of a conical funnel at the rate of 5 cubic centimeter per second. So sand at the rate of, which means it's volume, the rate of change of volume. If you are not able to identify this, you can just look into the unit and you can see this is a volume per time, right, which is rate of change of volume. If the radius of the base of the funnel is 10, which means you have the first radius to be 10. This is the funnel. The main radius of the funnel is 10. It doesn't change. The altitude is 20, which means this is 20. And then find the rate at which the sand level is dropping when sand level is dropping, which means the level of the sand is H, high. So this is your sand. So this is what is in the question. How does it change when it is 10 centimeters from the top? So when this is 10 centimeters. Okay. So what is given? dV dt is given, which is 5. What we have understood here is R1 equal to 10, H1 equal to 20, and we need to find dH over dt. So volume, start with the volume formula, 1 over 3 4 pi r 1 over 3 pi r squared h, and then we have dV dt. But the problem comes here. I have two variables r square and h square which needs to be differentiated with respect to t, which is not possible. Okay, because we need to find dH dt and we don't have dr dt. You cannot use implicit functions on this. If you use implicit function, you will be getting 2r dr dt over h times h plus r square dH dt, which means you need both dr dt and dH dt, which is not possible here. Therefore, we use the ratio which I just told you, r1 over r is equal to h1 over h, and we'll eliminate either r or h here according to the question. The question is asking for h, therefore you retain the h and eliminate the r. So what is r from here? R is equal to h r1 over h1. Okay, so what you do is you substitute in this volume. V is equal to, in this case, R1 is 10 and H1 is 20, therefore 10 over 20 would be half, therefore R is half H. Okay, substitute it in this volume. 1/3 of 4 pi 1 half of H the whole square times H in the place of R square. Now you have volume in terms of H only. Therefore you can find dV dt in terms of dH dt. Therefore you can substitute dV dt and find dH dt. Next is water flowing from a tank. So what changes does it contribute here? You can see that the height changes, the radius remains the same, there is no change in the radius, but volume changes, and also the surface area. Usually we don't bother about the surface area. Very rarely you'll get questions on surface area, but volume was more concentrated here. So volume of a cylinder pi r squared h. There is no change in r, therefore r is a constant. So you can see dV dt is equal to pi r square dH dt. So if either one of them is given, you can find the other one. It's easy with cylinders. The bottom of the cylinder water tank is a circular radius, circle of radius 30 centimeters, which means r is equal to 30. Water is poured into it at the rate of 350, which is dV dt is 350 because it's cubic centimeters. So dV dt is 350. Find the rate at which the level of the water in the tank is increasing. In this case, the level of the water increases as it's been poured into it instead of getting out. Okay, so it's increasing. The level of water increases, which means this is H. Therefore, you are asked to find what is dH dt. When the change of volume is given, dH dt is asked. So we know that dV dt is equal to pi r square dH dt because r is a constant. Now this would be pi, the radius is given as 30 square, and whatever you want to find is dH dt. So this gives you, this is equal to 350 because dV dt is 350. And give this with units, centimeters per minute, because it's how it's given here. Sliding ladder is a very good question. How does it actually connect with the rate of change? You might be wondering there. Say a ladder is leaning against a wall like this, and the yellow line is the ground and the pink line is the wall. And if the ladder starts sliding down like this, you can see what changes here. You can see that there is a right angle triangle formed here, and you can see that this hypotenuse is the ladder. As the ladder comes down, so there is no change in the hypotenuse. The distance, which is this, the ladder's height, does not change. Okay, but what changes? The height changes. So I can call this as y, and as it comes down, you can see that the length, the distance from the base of the wall gets increasing, right? Therefore this x changes, the y decreases and the x increases. So as the ladder drops down, you have dy dt, also you have dx dt, but dy dt is decreasing and dx dt is increasing. Okay, so what can you connect with? How do you frame the equation from this particular diagram? You have a right angle triangle, as I said, and the best way is to use Pythagoras theorem. H square is equal to x square plus y square. Okay, and h square is a constant. Say if the ladder is 20 meters, therefore its x square plus y square would be equal to 400. And if you differentiate this, 2x dx dt plus 2y dy dt would be equal to 400. And if you are given dy dt, you can find dx dt and vice versa. So you just have these two rate of change in this question. Okay, so you can see how y decreases and x increases there. A typical question: a ladder 13 meters long, so which is height, which is the hypotenuse, sorry, is leaning against a vertical wall. The bottom of the ladder is dragged away, which is x, from the wall along the ground at the rate of 2 centimeters per second, which means dx dt is 2 centimeters per second. How fast is its height on the wall, which is y, how fast, which is what is the rate at which it decreases, which means you are supposed to find what is dy dt at when the foot of the ladder is 5 centimeters away from the wall, when x is equal to 5 meters. Okay, so we know that 2x dx dt plus 2y dy dt was equal to h square, because I used the number 20 here, therefore it was 400, otherwise it would have been h square. So in this case h square is 13 square. Therefore x dx dt plus y dy dt equals 13 square over 2, and whatever this is, you can find it out. How can you find dy dt? Dx dt is 2, therefore you can write this as 2x plus y dy dt equals 169 over 2, because dx dt is 2. Now you can substitute x value, which is if you make isolate dy dt here, it is 169 over 2 minus 2x divided by y, because that's how you isolate dy dt here. In which case you need both x and y, but only x is given as 5, right? But what would be y? You should go back to your triangle. So this is 5, this is 13, so what should be this y? So that y should be substituted in this place. So x would be 5 and y would be what you found here, which should be 12. Therefore your dy dt at x is equal to 5 would be 169 over 2 minus 2 times 5 divided by 12. So this would be the rate at which the height of the wall decreases as the ladder drops down. Hope this is clear.